Hi everyone. In this session I am going to be discuss about the 01 knapsack using backtracking. So first I want to recall a very quick review on what is the 01 knapsack problem. We have n number of items. Each and every item has its own profit and weight. So P1 W1, P2 W2 and so on Pn Wn. Along those items we have one knapsack. Knapsack is nothing but a bag. So when we have a bag or a knapsack, it having certain capacity that we technically call knapsack capacity. The knapsack capacity in generally labeled as M. Here the problem is when we are going to be find all items weight summation or nothing but the sum of all items weight, sum of all items weight is greater than knapsack capacity. So that means all items are not possible to place into the knapsack. Our aim is which items are possible to place into the knapsack we are going to be placed with to get maximum profit. Nothing but our solution demands the maximum value. So that's why this application we called as a optimization problem or optimization application. Here the optimization is in the form of the maximization. So that's why the 01 knapsack is also called a maximization problem. So this is the first constraint. And the second constraint, which item we are going to be placed in the knapsack. For that, which items are placed or which items are not placed, we are going to be maintain one vector. That vector we called as solution vector. Solution vector size is the number of items. Nothing but how many items we have, n, that is our solution vector space. Each value in the solution vector either 0 or 1. Its value must be either 0 or 1. So 0 indicates that item not placed in our knapsack. 1 indicates that item we placed in the knapsack. So each and every solution vector value, nothing but x of I, must be either 0 or 1. This is our second constraint. So each and every solution vector value either 0 or 1. So that's why sometimes 01 knapsack is also called binary knapsack. Or binary knapsack application or binary knapsack problem. So after completion of this problem, we are going to be verify what is the profit we are getting and what is the weight of the total knapsack. We know the capacity of that knapsack, which items we placed into the knapsack. We are going to be find what is the total knapsack. So the total knapsack we are going to be find each and item which we placed in the knapsack, that is multiplied with its solution vector value. That means if it is placed, what is that value? 1. If it is not placed, what is that value? 0. So that is the total weight. Total weight is nothing but the weight corresponding solution vector is multiplied and all the partial multiplications we are going to be adding, nothing but the summation. So I equal to 1 to n, all items weight multiplied with all solution vector. So that is our total weight. This weight must be less than or equal to the knapsack capacity. My dear, earlier condition is the total items weight, but this one, which items we place into the knapsack, we want to know what is the total knapsack as of now. That value we are going to be get with each and every item weight multiplied with solution vector, corresponding solution vector. Those are all values we are going to be adding. So that's why sigma equal to 1 to n wi into xi. That value must be less than or equal to the m. And one more constraint, when you want to know what is the profit we are getting, so that profit nothing but the pi into xi. So for each item, if you place that item into the knapsack, that profit we are going to be consider. If it is not, that profit we never consider. What is the solution vector value? If it considering, it is 1. If it is not considering, 0. If it is not considering, 0 is multiplied with anything, we are going to be getting as a 0. So the profit we are going to be get always the maximization. So this is the problem statement of 0-1 knapsack. I hope you are good at that part. So now we are going to be solve this 0-1 knapsack problem with an example by using the backtracking approach. So what is a backtracking? Backtracking is nothing but it verifies all the possibilities and it finds if it having solutions, multiple solutions, find all the solutions. If there is no solutions, it verifies all the possibilities, then only it conclude there is no solution for this problem. But knapsack problem having some possible solutions, we are going to be find the possible solutions. So each item we are going to be represent in the state space tree in a node. Each node we are going to be represent 3 values. One is the next which item we are going to be consider. Second one, what is the current profit, and third one, what is the current weight. So that means when we are going to be create initially, first node, I want to create a node 1. I am going to be maintain the first, nothing but this is the first state, initial state. Initial, I never consider any item in my knapsack. So that's why next I want to consider the item 1. I hope you are good at the backtracking. Backtracking, when you are going to be find the solution for kth item, is it possible directly find the kth item solution? No. Whenever you want to find the kth item solution, before that you must be complete all the items up to k minus 1, then only it allows. So in the same way, initially there is no item. Next we are going to be consider the item 1 first. So that's why the next item number is 1. And as of now there is no item in the knapsack, that's why there is no profit, and also there is no weight in the knapsack. So that is the initial state. And the items we are going to be arrange in the order of the profit by weight must be greater than or equal to compared to the next item profit by weight. If the current item is I, next item is I plus 1, what is the relation? The profit by weight value must be greater than or equal to the PI plus 1 by WI plus 1. So that's why you will observe I am going to be arrange my items in this order. This is item 1, item 2, item 3, item 4. Why we are arranging the items in the corresponding order? In the sense, for writing our bounding function easier, we are going to be verify that bounding function also. So now I am thinking about the first item. The node left side, nothing but I am considering that item. What is that item? First item, x1 equal to 1. So the x1 equal to 1, nothing but I am going to be verify second item next. X1 equal to 1 in the sense, in my knapsack I have the item 1. When I place the item 1 in my knapsack, that corresponding profit also sometimes called as value. Already we discussed that in the dynamic programming. So profit or value both are the same. What is the profit we are getting? 40. So we are getting as a 40. When I place the item 1, what is the knapsack weight as of now? Item 1 weight only. What is item 1 weight? 2. So when I created that node, I must have a check what is the knapsack capacity. What is the knapsack capacity? 16. So what is the weight we are getting as of now? 2. So if the node weight as of now the weight is greater than the knapsack capacity, then we kill that property. So that's why for killing that property we are going to be arrange all the items in the profit by weight non-increasing order. So that is also called decreasing order. So I took the decision about x1. Then I am going to be think about my second item. What is the second item possibility? The same, x2, maybe the 1 or maybe the 0. My dear, it is a backtrack process. When the fully left complete, then only go for the right and so on. So that's why I am going to be construct the tree look like. So the next my decision is for the item 3. So what is that meaning? I have placed item 1 and also item 2. So now I want to place item 2 also in the knapsack. When I place the item 2, what is the item 2 profit? 30. Already I have in my knapsack with the profit as 40. 40 plus 30, 70. What is the weight of that knapsack? Already item 1 placed, weight is 2. Item 2 also placed now, weight is 5. 2 plus 5 is 7. I am going to be check. 7 is greater than 16? No. So that's why I never reach the bounding function as of now. I go with a extended that node. So the next I want to think about third item. So third item is nothing but so when I am taking the decision about the third item, and next item is the 4, and what is the weight, what is the profit? As of now I am getting 70, and what is the third item profit? 50. So 70 plus 50, 120. What is the weight as of now? The knapsack weight 2 plus 5, 7. What is the third item weight? 10. 10 plus 7, 17. Now check it. What is this item weight? 17. 17 is greater than our knapsack capacity? Yes. So when you reach that condition, that is the kill that possibility. That means unable to expand it. Then take the backtrack. When you take the backtrack, what is the node you recently expanded? This node. So for this node, is there any other possibility? Yes. We have verified only x3 equal to 1. We want to verify the x3 equal to 0. Good. Now I am going to be check x3 equal to 0. The fourth item. Next I want to consider, and a third item not placed in the knapsack, only item 1 and item 2. What is the weight I have? Profit is 7 and 70 and weight is 7. So now what is the current state weight? 7. So now I am going to be think about my fourth item. So the fourth item also having the possibility of it may be considered, may not be considered. So x4 equal to 1. If x4 equal to 1, which item I am going to be considered next? 5. What is the profit I am getting? 70 plus 10, 80, comma. What is the weight it having? 7 plus 5, 12. Now think. 12 is greater than the 16? No. You can expand this one. So is the fifth item is available? No. So already we reach. Then take the backtrack. So my dear, this is not the kill possibility. I have reached my end. So that's why I am taking the backtrack. So I feel this is the one solution as of now. But what is our problem aim? Problem aim is to get the maximum profit. So that's why I am going to be take backtrack. Here I have another possibility. Yes. What is that possibility? Fourth item may be 0. That means fourth item I never considered. What is this path? Item 1 consider, item 2 consider, item 3 not consider, and item 4 also not consider. So what does that mean? I am going to be consider the next is the fifth item, and my profit is as of now only the item 1 and item 2 profit, that is 70, and the weight is item 1 and item 2. Is there any fifth item? No. So I will take the backtrack. So as of now, what is the profit I am getting? 80 and 70. What is the maximum? 80 as of now, my dear. So I am taking the backtrack. So here I have verified all the possibilities for the fourth item. Yes. Then I take the backtrack. So now I am at this node. So when I am at this node, I have verified all the possibilities for x3. Yes, I have verified. No other possibility. Then I take the backtrack here. Now I am at here. So when I am taking the backtrack from this node to this one, I am going to be check. Is there any other possibility? As of now, I have verified only the second item into the knapsack. Now I am going to be verified with the second item not in the knapsack. That means which item I am going to be considered next? Third item. What is the knapsack profit I am getting? Only the item 1 because item 2 not place. And what about the weight? Only the item 2 weight, that is nothing but, sorry, item 1 weight, that is nothing but 2. So in my knapsack I have the only item 1 and item 2. Item 1 only consider. I took the decision about item 1 and item 2. Item 1 placed in the knapsack and item 2 not placed in the knapsack. So then I am going to think about this one. What about this one? x3 equal to 1. What about the x3 equal to 1? Nothing but I am going to be consider the fourth item next to be considered. If the fourth item I am going to be placed into the knapsack, what is this path? 1 placed, 2 not placed, 3 placed. Sorry, third item, not the fourth item, third item. I placed item 1 and item 3. What is the profit I am getting? 40 plus 50, 90. What is the weight I am getting? 2 plus 10, 12. 12 is greater than 16? No. I expand this node. x4 equal to 1 and x4 equal to 0. 5. What is x4? 1. Nothing but what is the profit? 10. So 90 plus 10, 100. What is the weight? Earlier we have 12. So 12 plus 5, 17. What is our knapsack capacity? 16. So unable to create this node, kill this one. Take the backtrack. So when I take backtrack, I am at this node. So what is another possibility? x4 equal to 0. So what is this path? 1 and 3 only consider, 2 and 4 ignored. So what is the next item? 5. What is the profit? 1 and 3, 40 plus 50, 90. What is the weight? Only 12. So as of now, these 3 are the solutions, which is the maximum 90. So this one as of now. So I am not satisfying. I want to take the backtrack. I am here once again. Is there any other possibility for the x4? No. I am taking one more step backtrack. I am at here. Is it possible to expand? Yes. As of now, I consider x3 equal to 1. Now I vote with x3 equal to 0. So then what is the values it having? 4. Which item I am including? Only item 1. Then what is the profit I am getting? Only item 1 profit. What is the weight of knapsack? Only the item 1 weight. So here once again I am going to be get x4 equal to 1 and x4 equal to 0. What is x4 equal to 1? Nothing but in this path I am going to be considered only item 1 and item 4. What is item 1 profit? 40. What is item 4 profit? 50, 10. So 40 plus 10, 50. Next I am going to be considered 50. What is the weight? The knapsack. Item 1 weight and item 4 weight. 2 plus 5, 7. 7 is greater than 16? No. So we continue. Is it possible to consider the fifth item? No. So this is a one more solution. As of now, 90 is the maximum. We didn't satisfy. We want to verify all the possibilities. Now what about the x4? We have the one more possibility. x4 equal to 0. That is nothing but I am considering only item 1 Item 2 and item 3 and item 4 ignored. So what is the next item? 5. What is the profit I am getting? Only 40. What is the weight it having? Only 2. So 2 is greater than 16? No. I am going to be expand. Is there any fifth item? No. I reached the dead end. As of now, this is also one solution, but the maximum we are getting as of now is the 90. I am taking the backtrack. So I am once again at this node. So for this node I have verified x4 equal to 1 and x4 equal to 0. Then I take the backtrack. There is no other possibility. Then I take the backtrack here. x3 equal to 1, x3 equal to 0. All I have verified. Then I take the backtrack here. Here x2, 1 and 0. I have verified all possibilities. Then I take the backtrack. I reached the root. Now for this root, as of now I have verified only one possibility, that is nothing but x1 equal to 1. And now I am going to be check with x1 equal to 0. So x1 equal to 0. If it x1 equal to 0, what is the possibility I am going to be get? Like next item is 2 and first item not considering, nothing but no profit and no weight. Okay, so what about the x2? x2 may be 1 or x2 may be 0. If it is 1, what is this one? We are going to be consider the next one is the third item, and only item 2 is placed, item 1 ignored. What is the profit you are getting? Only the item 2 profit 30. What is the knapsack weight? 5. 5 is greater than the knapsack capacity? No. We are going to be continuing. What is this possibility? x3 equal to 1 and x3 equal to 0. x3 equal to 1. What is that meaning? We are going to be consider the next one is the fourth item. And what about the third item including in our knapsack? When it is including, what is the profit it gives us? What is the path? x1 0, x2 1 and x3 1. Nothing but 2 and 3 only I am going to be insert. When I am going to be consider only the 2 and 3, what is the profit I am getting? 30 plus 50, 80. Then what is the weight? 5 plus 10, 15. 15 is greater than 16? No. So now I am going to be consider the fourth item also, x4 equal to 1 and x4 equal to 0. So what about the x4 equal to 1? We are going to be consider the next fifth item, and fourth item we include in our knapsack. Nothing but what is the fourth item profit? 10. 80 plus 10, 90. What about the weight? 15 plus 5, 20. So 20, is it possible? 20 greater than 16? Yes. So kill the node. Unable to expand this one, take the backtrack. So when I take the backtrack, I have the another possibility x4 equal to 0. So that means for fifth item in this path I have consider only the 2 and 3, nothing but the 80 and the capacity is 15. 15 is greater than 16? No, I am going to expand it. But there is no fifth item, I am stopping it here. And what is the profit I am getting in this path? 80. So earlier I got the 90. So I take the backtrack. I want to find all the possibilities. What about the 4? I have verified. What about the 3? We want to verify x3 equal to 0. If x3 equal to 0, what is the possibility? Fourth item we want to be consider next, and 30 as of now, weight as of now. 5 not greater than 16, we are going to be expand it. What about this one? x4 equal to 1. What is that meaning? Last item we are going to be consider. The next is the 5 and 30 plus 10 is the 40. What is the weight? 5 plus 5, 10. Is there any fifth item? No. We are getting one more solution. It may be the 40. So earlier may be the best solution as of now. So now go with unable to expand, take the backtrack. You are at this node, and we have the one more possibility, x4 equal to 0. So the fifth item, only item 2 is including in this path, nothing but item 2 profit only 30 and item 2 weight. 5 is not greater than 16. We try to expand, there is no item, we have the one more solution. So now I take the backtrack, I want to find all, then I take the backtrack here, x3 equal to 1 and 0 I have verified, then take the backtrack here. So x2 as of now only 1 verified, now I want to check with 0 also. So now I am going to be create with x2 equal to 0. So I am going to be create a new node. So what is that meaning? 1 not consider, 2 not consider, nothing but I am going to be consider third item and 0 profit, 0 weight. What about x3? x3 may be the 1, x3 may be the 0. If x3 consider, what about this value? Fourth item may be consider 50, and what is the third item considering? Only third item. What is the third item profit? 50. What is the third item weight? 10. 10 is greater than 16? No, I am going to be expand. x4 equal to 1. So what about the x4 equal to 1? Fifth item, 50 plus 10, 60. And what is the weight? 10 plus 5, 15. 15 is greater than 16? No. So this is one more solution. Take the backtrack, x4 equal to 0, nothing but 5, 50 and 10. This is one more solution. Take the backtrack and x3. So then you find x3, x4 equal to 1 and x4 equal to 0. So out of this all, what is the maximum value we are getting, maximum profit? You are going to be check except the killing nodes. So that is nothing but this one. So in this way we are going to be find the 0-1 knapsack problem, or we are going to be solve 0-1 knapsack problem using backtracking approach. So then what about this state space tree? Is it look like? It will be look like nothing but each and every possibility gives us the other possibility, nothing but order of 2 power n. So this is about the 0-1 knapsack using backtracking. So thank you.